Anyways, what I was saying is I will just go ahead and I will just complete my recurrent neural network implementation in Excel. Okay, before I copy, let me just make sure anything that's supposed to be hard-coded is hard-coded. Okay, I think it's supposed to be hard-coded. That's supposed to be hard-coded. Okay, so now that everything is hard-coded, what I'm going to do is I'm just going to go ahead and I'm going to copy this and paste it into, so now we'll be working backwards, right? So copy this, start pasting it to the previous layers and just backpropagate. Oops. Just make sure I have enough cells first. Should. Okay, now just double check my formulas. Make sure nothing looks odd. This is a lot more annoying than I thought it was going to be. Okay. Okay, that's done. The hidden. Okay, that looks about correct to me. So we're taking dy, multiplying it by our weight, 3, and then we're adding delta hidden. Now delta hidden raw, that is, okay, not really much needs to be checked there. Looks like it's working. Bias for our hidden layer. This one I know for a fact. will not be correct. Let's check that. Okay. Okay, now delta for weights 1. This one would be input. Okay, it's got the input correct. And then DH raw. And then we're adding that to okay. That looks correct. We're adjusting our weight so slightly. And then the hidden. So that's taking the output from the previous layer. So okay, yeah. From previous layer. And so then why does this have an issue? Gotcha. Yeah, so your previous hidden is just 0. Okay. And then this one is just DH raw, delta hidden raw by the weights. That should always stay the same. Yep, should stay the same. Okay. Now what I'll do is, now that we have our deltas, what I'll do is, now let's start updating them. So I'll just copy our weights that we have here. And I'll just add them over yonder. Take this guy and bring him over here. And so then what I just want to do is just want to make sure that just want to prevent exploding gradient. So what I'll do is so for these weights, what I'll do is I will take minimum of these guys and okay. So I want to clip it between -5 and 5. That's what I'm going to go with just for clipping purposes. Trying to figure out how to do this best. Okay, so to clip it, all I have to do is just say, okay, take this maximum of that and -5, and then do the same thing, minimum of that and 5. That should achieve the clipping I'm looking for. Okay, so I have to do it individually. Okay, it's a bit of a hassle, but then finally add it to our original weights. Okay, so this guy is W3, you're taking that, you're clipping it between plus and -5, and then you are W3. Okay, that looks like it works to me. And then bias, we're going to do something very similar for our bias, except that obviously we're going to go to our bias 1. Yes, bias 1. And we're going to add L7 to it. Yeah, okay, that seems to be correct. Okay, just double check our formula. Third bias node, third bias, looks good. And then we're just going to do something very, very similar for these weights as well. So you're going to take that, and you're going to take whatever is here. That's what you're going to do. And this is for yeah, I'm still very, very, very confused about what to do with bias. That actually might derail everything, to be very honest. But we'll see. Okay, lastly, I'm going to work with the third weights. We're just going to do our update, make sure everything's clipped. And then our bias update is going to be quite similar to it. Okay, so once again, everything has been built out. We have our feed forward for all the different time steps. So time step 1, we're inputting H into the neural network, then E, L, L, and then we want the AI to output the word hello. So we have feed forward implemented, and then we also have the backprop implemented so that the AI learns and the weights are updated, and we just feed them backwards. So I think we are good to go. Just double check this. Why is that? That number doesn't look. Oh, okay, that is updated. So I think we're good to go. What I will do is I will go ahead and I will start creating our macro. So again, the macro is just will help me automate in Excel, because essentially what we want to do is we just want to copy these weights here, and then we just want to paste them in their respective sections. Actually, hold up. No, I forgot to incorporate learning rate. Back up before we do that. Okay, so what we want to do is we don't just want to update the weights. We don't want to use the delta to update the weights immediately. What we want to do is we want to update them. We want to slightly nudge the weights in the right direction. And so in order to do that, we're going to use a parameter called the learning rate to control that. So I already have learning rate built out here, and that's what I'm going to do. So what was it, B2? Okay, yeah, it's B2. Oh, sorry, B1. Okay. Okay, I'm just going to double check there's nothing wrong with the formula. We have that there, multiplied by the learning rate plus that. Okay, guys, let's go. So let me just run through in detail what one simulation instance would look like. So once again, we have our different time steps. So time step 1, H, time step 1, H, it goes through our neural network. So where's my whiteboard? Oh, I gotta oops, I was supposed to summarize what neural networks are, or sorry, how the recurrent neural network works. You know what? We'll do that later. Unless anyone really gets mad that I didn't do it, then I'll go back and do it. But it's 2 people that watch this. So at this step here, we have a time step 0. Just initializing the memory of the neural network, or the recurrent, or the RNN, and so the memory of that is blank when we first start. So the first time step, we're going to be inputting H. So we're here in the input, we're inputting H into the network, and then it goes through, it gets multiplied by the weights, which would be these lines here, and that would give us the current, the raw output. The raw output, what we do then is we pass it through, so we have the raw output. Then what we do is we go back to the old hidden state, and then we add that hidden state. We also multiply it by its weights as well. So now we have 2 different types of, we have the product from this multiplication. We also have the product from this multiplication. We add them together and pass them through an activation function. So in this case, I'm using sigmoid, and that gives us the hidden layer output. And so then from there, what we want to do is we want to then actually have the network make a prediction. And so then we multiply it by the weights, which are these black lines again, that connect the hidden layer to the output. And that gives us our raw output. Then because we want it to format the output in terms of probabilities, then what we do is we then pass it through something called a softmax activation, which essentially just sums everything up to 1 and gives us a probability. So essentially it's telling us, okay, so I've seen H, you've given me H for time step 1. I'm predicting with my prediction is the next letter has it should be E, right? So it's like a 42% chance of being E, or sorry, it's essentially just like a confidence. I'm 42% confident that the next letter should be an E within this word hello that we're training it to output. So it does that for layer 1, and then, time step 2, we're doing the same thing, except now we're inputting E into the network. And so here, when we're grabbing the previous hidden layers output, we're taking this guy, so the activated function, we're multiplying it by the weights, do the same thing again. So we add the two products from these sets of weights and these sets of weights. We pass them through the sigmoid activation, and then we multiply by the weights again. We get the output, and that gives us E. And so then we rinse and repeat that same formula for L in time step 3 and L again in time step 4. And then it passes through the network and gives us an output for each and every single time step. Then what we do is then we want to go backwards. And so going backwards, we then initialize our delta weights. So all the weights are the same. And so delta weights just helps us to keep track as we're backpropping backwards or backpropping through time, keep track of all the changes that we need to make through the weights from the previous or from all the different layers that we're backpropping through. Then what we do is we first start with the error. I guess this is my explanation of backprop, kind of whatever. So we start with the error, and then we want to go from we want to go from this node to that node. So this is the loss, and then this is the output activated value. This is the output raw value. This is the hidden layers activated value. This is the hidden layers raw value, and then this is the actual raw input for the current time step. So this would be the previous time step, and this is the current time step. So we've gone our loss. Then what we do is we just start going backwards. So in order to go backwards from the loss to output activated, what we want to do is we just want to find the derivative of softmax, which is what we calculated here. So derivative of softmax, and then we work our way backwards throughout the network. So in order to update these weights that are here, what we do is we just grab the output derivative, we multiply it by the weights, and so that's what we get. That's what we get here. So delta weight gets, or we adding to delta weights the derivative multiplied by the weights. Where's 37? Oh, sorry. The derivative multiplied by the output from the layer. Okay, sorry. What is this again? That is here. No, okay. I guess that's how the math works. You multiply it by so we multiply it by this node in order for us to go backwards. I guess that's how the math checks out. How the heck does that make any sense? Oh, right, okay. Yeah, okay. That makes sense because we want to update the weights, so we multiply it by what was inputted into those weights to actually give them the output. Okay, that makes more sense. Okay. Okay, so that's that. And then what we do afterwards is then we then update the bias as well. So the bias will just be the bias plus the error. I don't know why this is the case, but apparently that's how the math checks out. I haven't sat down to like look at any proofs as to it's how the math is. How the algorithm works. And so then what we want to do is, so then now we want to calculate the, so we're done with this section. Now we want to move backwards. So in order for us to move backwards, we just want to grab the weights for y, and we want to multiply that by our output delta. And so that will help us move from this layer to the other layer by multiplying it by the weights. Then what we want to do is we want to grab our hidden output derivative. So the hidden output derivative is just is moving from this node here, which is our activated, to the raw output. So we have to multiply it back, and we have to pass it through where we have to get the derivative of the sigmoid activation function that we've used, and then we multiply that by the hidden output derivative that we have here as we're making our way back sequentially through the recurrent neural network. And so then for our bias, what we're doing for the bias is we are just adding. For bias, we're adding the output, the hidden raw derivative. It's how the formula is, it's how it checks out. I don't fully know why that is, but again, I haven't really sat down to try to find the mathematical proofs for it because I kind of just want to move on. And so then the last thing we want to do is then we want to start updating this set of weights here and then this set of weights here that connect the hidden layers together. So what we're going to do is. But keep in mind that these are two separate layers. So there's the hidden in here. No, sorry. So this is where the hidden weights would be, and then there's only one set of weights here, which is the one that connects the input to hidden, and yeah. Okay, so then in order to update our weights, we're going to start with this set of weights, or these set of weights first. So what we're going to do is we're just going to add to the previous, or whatever is currently in the delta weights, or because we're backpropagating through time, so we want to keep track of all the changes that need to be made over time. What we're going to do is we're going to add to that delta weights variable the product of this raw derivative and the input. So again, because we're moving from here to here, we're going to have to multiply by the inputs that were actually given to this this layer. Sorry, not the inputs. Just the. No, yeah, I'm right. The inputs. The inputs, and we're going to multiply them by the hidden raw derivative. So the hidden raw derivative is the derivative of the output for that layer, and then we just multiply it by what was inputted into the layer. Similarly to what we did with the previous when we were updating the first set of weights. So the first set of weights, if you remember, the set of weights, what we did was we grabbed its output derivative, so what caused the output for the third layer, or for the output layer. We grabbed the derivative of it, and then we just multiplied it by what was inputted into that layer, which is just what came out from this section over here. And so then the last thing we just want to update is the delta weights 2. So delta weights 2 is basically just the weights that connect the hidden layer to itself. And so it's pretty much the same thing. Pretty much it follows the same formula, really. What we're going to be doing is, well, what connects the hidden layer to this output, or to the raw output? Well, what connects it is the previous layer's output, previous layer's activated output, and the weights, right? So what we're going to do is we're going to multiply it by the previous layer's output, which is what I grabbed over here. And we're going to multiply it by the set of weights that the set of weights. Why am I not referencing the set of weights? What am I referencing? Oh, no, sorry. Not a set of weights. I made a mistake there. My bad, scratch that, not a set of weights. We're multiplying the output by the derivative of, what was given in this, what was outputted in this specific state. So hidden raw derivative by the input that we got for that. So that would be the input from the previous layer. So essentially just backprop, you're just doing what causes output. Let's find if you pass through an activation function, let's get the derivative of the activation function. If it passed through a node, or if it's, that now after you go you past that, now you're in the layer, or now you're in the layer, or the raw output layer, then how do you move backwards, or how do you move back? Essentially, to get the derivative there is that you just want to find, well, what caused that specific output, what caused that raw output. And so now you have the output derivative, so you multiply the output derivative by the inputs that were actually inputted into that layer, for that layer to get that raw output, right? So again, if we take a look here, if we want to move from this raw output to the previous layers before it, what we would want to do is we want to take the derivative of the activated function, which multiply it by whatever input it got. And so that's essentially just the formula for backprop, and that's essentially what we've done over and over and over again here for weights 1, weights 2, and weights 3. Now, what we want to do is we want to also keep in history just what is. This is something I'm still trying to get fully understand, but this is needed in RNNs, again, because we are backpropping through time, and so this is that time related piece, and so I'm just calling it delta hidden. And essentially what it is we are just grabbing, let me see if I can actually make sense of it right now. We're grabbing the raw hidden derivative, and we're just multiplying it by the weights. Okay. Multiplying it by the weights. Yeah, I don't know why we do that. I guess I'll either figure it out later, or it'll come to me when I go over this a couple of times, and I'll have a better explanation once we get there. And so that's in the last time step. So in the last time step, that's what we do. This is time step 4. So we're doing this in T4, and then we got to roll it up, right? So you do it in T4, and then you go back and you do it for T3. You go back and do it for T2. You go back and do it for T1, and then you essentially update the weights. And so in Excel, for us to update the weights, all I'm going to do is I'm just going to copy here. Actually, sorry, what I'm going to do is just Shift F9, just make sure I run all the formulas, copy here, and then just go ahead and paste it here. And so I'm going to repeat that for weights, second set of weights. Again, I don't really know what to do with the third set of weights. I don't really know what to do with the bias just yet. We'll get there. So one of the reasons why I have it set to manual calculation is so that the neural network doesn't start updating while I'm still copying the weights over. So now what I'm going to do is when I hit Shift F9, it's going to refresh all the formulas. Everything's going to be recalculated again, including all the backprop stuff, including all the weight updates. And so this is just the step. So, I'm just going to continuously copy and paste, copy the new weights and copy them into the old weights. And so in order to automate this, because I don't want to sit here and do this 100 times manually, what I'm going to do is I am going to record a macro. So I'm going to call this update RNN. I'm going to put Control Y, just a random. So what it is all we're doing is, refresh, make sure everything's refreshed, Shift F9, copy here, and then come here and then paste value, so HVV, then go back to it, copy this set of weights, paste them in there, come back, copy this set of weights, and then paste them in here, and then once again just hit that refresh, let it refresh, and that is our macro. So I'm actually just going to open up Visual Basic just to make sure that the macro is working. Okay, there we are. What I'm also going to do is I'm actually just going to add a button. It's not going to be like the most beautiful thing, but update RNN, okay. And I'm just going to have this update. I haven't coded VBA for a while, so I don't know the exact, off the top of my head, but I guess this is it. The exact notation just to automatically run our macro a couple of times. So should be an end at the end there. So there's essentially what I'm adding here is just that this will just repeat. Oh, sorry, next I, my bad. Yeah, because there's a for loop. This will just repeat our macro, and I've set it to 1,000 for now. So just go ahead, save, and 1,000's a lot. Let me do 100. Okay, so we're gonna sit back. It's gonna go update for 100 times, and we're gonna see what happens. And I just really hope my computer doesn't crash right now. This is quite scary. Oh, okay, that was quick actually. Are you done? Are you frozen? What's going on, computer? Talk to me, son. Okay, I think it's done. I don't think that's learned anything, but okay. Let's run it 1,000 times. See what happens. If it doesn't learn in like 1,000 epochs, then yeah, there's something grossly wrong with it. That was a pretty dramatic completion. It's quite dramatic for an ending. Alright, let's see what happened. Okay, it's the moment of truth. Drum roll, please. Where the heck is my output? Where are my outputs? Oh my god, this thing learned nothing. So basically what it's telling me is yeah, this is a really dumb AI. Every letter you input, it just tells you the next letter should be E. You input H, it says next letter is E. You input E, it says next letter is E. If you input L, it says next letter is E. Put L, it says next letter is E. So he, E, Lee. Those are the words my AI knows. Okay, so one thing I'll do is I will revisit how bias is yeah, the total loss just went up over time. Oh, actually, another thing I also want to do is you know what? I'll do that next time. I also want to just graph how the total loss is decreasing over time. That is one thing I did implement for. Actually, let me just go here. That is one thing I implemented here, just to see how error decreases over time. You know what? Let me just copy that. You know what? Let me fix bias. Let me fix the bias first, and then I'll get to that. Why did it not work? That's my question. Yeah, honestly, it should have worked. Okay. Yeah, let me just fix the bias first, and then we'll see what's going on. Hopefully that fixes it. If it doesn't, I don't know what to do, to be very honest with you. So it looks like bias for RNNs are a separate beast. So what I will do is I will bias one. I'll just separate it off. And this is just what I want. If I want it reset, replace this with exclamation marks. And so now how the hell does that make any sense? Oh, okay, I see what you're saying. Okay. Get rid of that. Get rid of that. So that's that. Plus the previous layer is equal to that plus that. And then here's where I'm going to add the bias. Okay. And we're just going to copy this. So I copied this as well. Okay. Yeah, no, for this one I can keep that there because there's only one layer for it, so I can keep the bias there as that. Now it outputs H for everything. This neural network is pretty stupid, I won't lie. Okay, now let me go back into Visual Basic really quickly. And what I need it to do is I need it to, you know what, screw it. Let me just record a new macro. Macros, gonna delete that. Yes, delete it. Actually, no. How the hell do I do? Huh, interesting. Okay, so this time when I'm recording my macro, what am I going to call this? Update RNN. This time when I'm recording my macro, what I'm going to do is, okay, hold up. Actually, stop recording. You will now be grabbing from there. This bias is now its own separate entity. Okay. Try to record the macro again. Yeah, delete, update RNN. Record a macro. Update RNN. Refresh, hit Shift F9. Copy these guys. Paste them here. Paste values. Copy our bias. Paste that guy here. Paste his values. Copy weights. Second set of weights. Paste them there's values. Copy everything here, including the bias. Paste his values. Do Shift F9 and then come and then grab our, come here, insert a new row, come back up here. Where's our error? Copy our loss, and then just paste as value into there, and we're done. Okay, so that last little part is essentially just keeping track of the error. So after it updates the weights, it hits Shift F9, which is to refresh the whole, the neural network using the new inputs, and so now we get new outputs from it. And I just want to keep track of that error as well. And so what I had to do was I had to insert a new line. So every single time it goes through, it just inserts a new line, and then it pastes the new error on top of that. So that's the only way that I found that you can use a macro to just stack values on top of each other. Otherwise, it just starts to overwrite different values. So go back into here. And what I'll do again is I'll just copy, oops. Copy this bad boy, bring him into here. Next, I save that, come back in here, and round 2. Hopefully this works this time, but we'll see. Okay, I might stop training because I can see that the error is increasing, meaning it's not learning anything. I'm an idiot. Oh man, I flipped a sign somewhere. We found the gradient, meaning that we're going down, but I'm adding to the... What the hell is wrong with me there? Okay, so this should be... this essentially should just be a minus. So our gradient that we found here is what helps us go down the slope, and so we just want to subtract it and make sure we're going down to reduce our error. I don't know why the hell I added it. Why do I have to be so dumb sometimes? Okay. Subtraction. Why does it look like this number didn't change? Why is this number not changing? Okay, am I going crazy or? Oh, it is. Gotcha, because of the learning rate. Okay, okay. That's that. That. I can't believe I made that simple silly mistake. I was adding to the error rather than subtracting from it. Ha 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 ha. So with that. You know what? Let me add this back. Add this back here. No, I still have to keep it separate. Because especially with the way matrix multiplication works, yeah, I have to keep it separate because it's adding. It should be added rather than multiplied with. Okay, let's see if this makes it learn anything. I'm confident. I'm confident that this will work, and I'll tell you why I'm confident. I'm confident it will work because what was happening is that the error was increasing, meaning we were going in the opposite direction of what we wanted, which to me seems to be like if we just flip the sign, then error should be decreasing, right? So I'm confident that this will work. Let's hope it works. All my delta y. Where's all my stuff that's down here? Ah, crap. Okay. Whoops. So what I just need from you is to just bring all these guys back up. Shift cells up. Hopefully doesn't have an effect on anything. Okay. So I'll got my error 7.59. Add it there. Save everything. and then let's go train again. So now it should be decreasing. It looks like it's decreasing. 7.54, 7.52, 7.51, 7.5. It looks like it's working. 7.46, 7.42. It's definitely decreasing. And so we just let it go for 1,000 times, and we see what happens. I'm using vanilla. I'm not using any. Yeah, I'm just using vanilla. What's it called? I forget exactly what it's called. It's like vanilla update or anything like that. So I'm not using Atom. I'm not using momentum updates or Nestrov's momentum updates. So learning will be a little slow, but dude, it looks like it's going in the right direction, man. I am. Whoo, I'm proud and happy. We did it, guys. We did it. We built it. Seems to be learning. So it's going to take its sweet time. And I'm just going to go back and just do some more engagement with the community, Twitter community. And I have to take a look. I have to pop my head up and just, it's going down, guys. Started at 7. Now it's at 7.6. Now it's at like 5.9. I'm nerding out over just numbers. Excited just by numbers. What I should start doing is, if I'm ever building an AI model and I'm just waiting for it to train, what I should do is I should make it like a live stream, so that I get some community engagement going on as well. But I mean, it doesn't really matter to me. All this part could either be, depending on how I edit the vlog or how I edit it's just one vlog. Depending on how I edit the vlog, all of this could be kept in. Even when it comes to the full coding video, I might cut this out as well, because you don't really need to sit there for like 5-10 minutes and watch the model train, right? I can just show you the training results at the end. But if there was community engagement, that would make this section, that would add a lot of value to this section. So that's something I got to take a look at. But oh man, we started at 7.6, we're at 4.9 now. Oh, it's finally training. Oh. I think it's going to need more than 1,000 epochs though. But what I'll do is, after it's done training, I'll just visualize the error and just see what's going on. If it's plateaued, then I don't know what to do actually if it's plateaued. But if it looks like the error is still decreasing at the same rate that it was at the very beginning, then I'll just train it for more epochs. I need to create a Twitch account. I should probably create one. First, though, I need to get my website up and running. My website was like the first thing that I created before my YouTube channel, before my Facebook, before my Instagram, before my Twitter and TikTok and all that. And like, it's still down. I haven't even published anything on it yet. So something I gotta do. I think we plateaued. This is an error of 3.6. I think we've plateaued. Yeah. Oh well. I'll let it finish training and I'll see what happens. It did go from 7 to 3, so I think that it's working well. And when I connect it to, when I connect it with things like, actually, how does AutoGrad work? Sorry, how does Momentum work with RNN? I'll figure it out. Okay, let me just graph, out of curiosity. Let me just graph this. Sure. Yeah, it looks like it's plateaued. I always forget how to do this. How do I reverse this on her? Okay. But in terms of our output, oh, that doesn't look good to me. I mean, almost, kind of. What do we start with? I forget what we started with. But it's learned that after an H should come an E, and then after HE should come L, after HELL, another L. The only thing it did not learn was O at the very end, which, you know, if I was to initialize and if I was to train it again, perhaps it would learn that, but it worked. It worked. That's all that matters. Well, I mean, kind of. It's, whatever. Okay. I'm just taking a step back just to appreciate what has just happened. Okay, so a couple of things. One, I will need to figure out how to connect or how to add other update methods to my RNN. One I want to add is Nestrov's momentum, and also standard momentum as well would be something I'd want to add to. I want to add to the RNN. And then, so I'm going to do that. So that's going to be tomorrow. And essentially what those do is, let me see if I can actually show my error graphs. So basically what they do is they allow the network to train much, much faster. So in this standard neural network that I have, this here is just a standard XOR gate. So, you know, it's a gate that has two input nodes, input 1, input 2. And so the output of it is 1 if either input 1 is a 1 or input B is a 1, but not both, right? So if both of them are zeros, it'll output a 0. If either one of them, if exactly one of them is a 1, then it'll output a 1. If both of them are 1s, it will output a 0. So in that very simplistic problem set, you can see here I've graphed out how the neural networks, how the different update methods. What are they called? They're called, forget what they're called. update methods. I don't know. Yeah. I guess I was right. Yeah, so you just essentially see how the different update methods perform. So momentum is quick. Nestrov's momentum is quick as well. But the vanilla update, which is what I've implemented for the RNN, that is quite slow and it takes it quite some time to learn. And so that's exactly what's happened here. It's just taking way too long to learn. I could probably have it go for another 1,000 epochs before it actually plateaus, but it's definitely getting there. I would say at about 500 was where the trajectory started to change and it started to plateau just a little bit. But I could probably have it go for another 1,000, and in that second 1,000, and so that's what I'll do while I'm editing today's vlog, just to see. And so in that second 1,000 epoch, it'll most likely learn and most likely tune and just iron out this last kink of it, where it's not able to. Where is it? Where it's not able to. Where it's just getting the final output wrong. Yeah. So I'll do that while I'm updating, while I'm editing the video. I'm gonna add update Nestrov and momentum update tomorrow. Another thing I want to do is yeah, no, I think things like dropout and regularization, like L2, I don't really think they would change too much from a standard vanilla neural network, right? I think it's all kind of the same. But so that's the plan for tomorrow, and then we go to LSTMs, implement that in Excel, and then after we're done with both RNN and LSTMs, we finally start to implement them in code, and then we hook them up to our tic-tac-toe game, and then we are done major AI number 3 for tic-tac-toe, and then there's one more type of AI we'll get to. So we're getting there. We're moving. We're making moves. That's it for today. Thank you guys for watching. See you guys tomorrow.